For hundreds of years, the basic idea behind a shotgun was remarkably simple. Put a projectile in a barrel, ignite a propellant, and send the projectile toward a target. But there was a problem. After every shot, the gun had to be reloaded, and engineers spent centuries trying to solve that problem. The result was a long evolution from simple muzzle loaders to repeating, pump-action, and self-loading shotguns. So how did we get from one shot at a time to the shotguns we recognize today? Let's go back to the beginning. The muzzleloader early shotguns were muzzle-loading firearms. Everything had to be loaded through the front of the barrel. The propellant went in first, followed by the shot and other components needed to keep everything in place. Then the weapon had to be prepared for firing. Once fired, the entire process had to be repeated. It worked, but it was slow. And that created the first major engineering challenge. How do you make the next shot faster? The answer wasn't simply making the barrel better. The entire loading system had to change. The break-action shotgun. Eventually, designers developed firearms that could be opened at the breech, the rear of the barrel. Instead of loading everything from the front, the user could open the action and access the rear of the chamber. This became the foundation of the break-action shotgun. The design was mechanically simple. Open the action, load, close it, fire, then open it again to reload. Double-barrel versions could hold 2 shots, giving the shooter another major advantage over the old single-shot muzzleloaders. And because the mechanism was relatively simple, break-action shotguns became extremely important and remain common today. But engineers still wanted something better. Why stop at 2 shots? Repeating shotguns. The next major step was creating a shotgun that could carry multiple shells and feed them into the chamber one after another. This introduced a completely new engineering problem. The firearm now needed several mechanisms to work together. Store ammunition, move a shell into position, lock the action, fire, extract the spent shell, and prepare the next one. That transformed the shotgun from a simple single-loading firearm into a repeating mechanical system. But there was still a catch. The shooter had to manually operate the mechanism between shots. And that led to one of the most recognizable shotgun designs ever created. The pump action. The pump action shotgun introduced a remarkably intuitive idea. Instead of opening the entire firearm and manually loading another shell, the shooter could operate a sliding forend to cycle the action. The movement mechanically coordinates the action, allowing the firearm to eject the spent cartridge and prepare the next one. This dramatically increased the speed and practicality of repeating fire compared with older single-shot designs. And the design became famous for something else: simplicity. The basic operating principle doesn't require the firearm to generate enough energy from the fired cartridge to cycle itself. The action is mechanically operated by the user. But engineers had another question. What if the firearm could cycle itself? The semi-automatic shotgun that led to semi-automatic designs. Instead of requiring the shooter to manually operate the action after every shot, these shotguns use energy from the firing cycle to operate the action. Depending on the design, that energy can be harnessed through different mechanical systems. The result is a repeating cycle in which, after a shot, the action automatically moves through the necessary stages to eject the spent cartridge and prepare the firearm for the next shot. The shooter still has to press the trigger for each shot, but the manual cycling step is gone. This was another major change in shotgun engineering. The shooter no longer had to provide the mechanical energy needed to cycle the action. The firearm could do it itself. So why do different types still exist? At this point, you might expect one design to completely replace everything that came before it. But that's not what happened, because every mechanism involves trade-offs. Break-action shotguns are mechanically straightforward and easy to inspect. Pump actions are known for their robust manual operating system. Semi-automatic designs offer faster cycling with less manual action, and different shotgun configurations can be optimized for completely different purposes. So the evolution wasn't really about creating one perfect shotgun. It was about solving different engineering problems.